So here we're going to calculate what percentage of the unit cell is filled with atoms. And we'll see that the different unit cell types that we've talked about are filled different amounts. So basically, to come up with the percent filled, we're going to consider the volume of the spheres inside the unit cell divided by the volume of the cell total. And then, to make it a percentage, times 100%. So if we start with a primitive cube, we can figure out this percent filled by first calculating the volume of the spheres. Now we said that there's one atom inside a primitive unit cell, and the volume of a sphere, any sphere, is 4/3 pi r cubed. Now the volume of the unit cell itself is going to be the edge length, whatever that edge length is. Volume equals the edge length cubed. Now we need to think about the edge length in terms of the radius of the spheres or the atoms. In the case of a primitive cube, the atoms touch each other along the edge of the cube. So the lattice parameter A is going to be 2 times the radius of the atoms, and the volume will be 2r cubed. So if we come back to our calculation, we enter in the volume of the cell is going to be 2r cubed. Okay, then we end up with 4/3 pi r cubed divided by 8r cubed. So look, our r's cancel. It doesn't matter what size the atom is or what atom we're talking about. And if we, collapse all of these constants, we get a fraction, 0.523, or, so times 100%, means that 52.3% of a primitive cube is filled by atoms. If we do the same thing with a face-centered cube, then we know that now we have 4 atoms in the unit cell times 4/3 pi r cubed. And so to calculate the volume, we're once again going to want the size of the edge length A, but we're going to need that in terms of the radius. Now, the atoms in a face-centered cube don't touch along the edge length. Instead, they touch across the face diagonal. So the face diagonal will be 4 times r. 1, 2, 3, 4. And so if we do our Pythagorean theorem that a squared plus a squared equals 4r squared, then we work out that the edge length is 2 square root of 2 times r. And so then the volume will be 2 square root of 2 times r cubed. And so if we put that back into our volume formula, we get 2 square root of 2 r cubed. And so that comes out, so we've got 16/3 pi r cubed divided by, if we do 2 square root of 2 cubed, that comes out to be 22.62 r cubed. Once again, the r's cancel, and our fraction comes out to be 0.74, or 74%. Finally, if we do the body-centered cube, then we can find out that the percent filled equals, here we only have 2 atoms in the unit cell, so 2 times 4/3 pi r cubed. Now, to find the volume of a body-centered cube, this one is even more complicated because the atoms touch along the body diagonal that runs through the unit cell. And so we have the edge length A as one of the sides of the triangle, but the other one runs across the face diagonal. So if you picture just the face of the cube, then one of the face diagonal would be equal to some value. And so you could work out that, like, if you do your Pythagorean theorem, you can work out that for this triangle, the body diagonal is 4r, and that face diagonal is going to be 2 square root of 2 times the lattice parameter times r, like we worked out in the previous example. And so then if you put all of those together, you can work out that the edge length, the lattice parameter, is 4 times the square root of 3 times r. And so if we put that back into our volume formula, and so again, that's geometry. You can remember what middle school you or high school you thought about geometry, but we're going to work this back to 4 divided by the square root of 3 quantity cubed times r cubed. So once again, r cancels, and if we collapse all of those constants, we will see that our fraction is 0.68 times 100% means that 68% of a body-centered cube is filled with atoms. So we see that the primitive cube is the least packed, and the face-centered cube is the most packed. And that face-centered cube is what we will call a closest packed structure. It turns out that you can't really get more than 74% of the volume of the cube filled. But we also see that the body-centered cube isn't far behind.